Finding the remainder between the division of two integer variables can be very handy when you're determining whether a number is even or odd. Let's look at an example. Let's have an int first num, assign the value of 10, and int second num and give it the value of 3. Now if we just print to the screen first num divided by second num, what do you think you'll get? So the value of this in the calculator will be 3.3 reoccurring. So we'd actually just get 3 because it's truncating it because of the integer. So now what happens if we need the remainder between both of these? You could actually work this out by seeing how many times 3 would be divided by 10 as close as possible, and you'll see the value is 3, and then 3 times by 3 is 9, which will give you 1 left over for the 10. But that's a bit too long in our code, so we have something called a modulus operator. So we can actually change this divide for a percentage sign. And what this will output is it will only give us the remainder. So let's say 10 divided by 3 is 3.3. As we've just said, but the remainder is different. Remainder is exactly how you learnt it at school. 10 divided by 3 is actually 3 remainder 1, because 3 times 3 is 9, and then you have 1 left over to get to 10. So that'll be 3 times 3, which is equal to 9, and then 1 left over to get to 10. So now let's run our code and see if we do actually get 1. There we go. So the best way to determine if a value is actually odd or even is to divide it by 2. So we can say 10 modulus 2, and if the value is 0, then that means the value for first num is actually even. If the value is 1, then it's odd. And let's see how this works out. If we had 10 modulus 2, then the value is 0, because 10 can be divisible by 2 perfectly. Let's say we had 11 modulus 2. The closest multiple to 11 is 10, which is 5, and then we have 1 left over. So you just have the remainder is equal to 1. And if we just keep going up in the chain, we'll realize that it's the same pattern. Every single time you go up a value, the value just toggles. So when we print this out to the console, and the value is actually 0, that means the number is even. And if we make the number odd on purpose, and then rerun the code, you can see that it's a number 1 now, which means this value is now odd. So let's look at a couple of examples and see if you can figure out the answer. If we do 1000 modulus 90, what do you think the value will be? And let's write a couple more. If we do 100 modulus 90, and maybe something like 71 modulus 10. So have a think about this in your head and see if you can figure out the answers. Pause the video and see if you were correct. Let's take a look at the answers. So we can see we have 10, 10, and 1. So the closest multiple to 1000 from 90 is 990. So we have 10 left over to get to 1000. And the same goes here. The closest multiple of 100 to 90 is just indeed 90. So we only have 10 to get from 90 to 100. And in this case, the closest multiple of 71 to 10 is 70. And we have 1 to get up to 71. Therefore, these two answers are indeed correct.